In this video, we're going to take a look at the fundamental theorem of calculus and how it's used to find the area between two values on the x-axis, the curve, and vertical lines between those two values. So the fundamental theorem of calculus states the area below a curve of a function y equals f of x and above the line y equals 0, which is the x-axis, to the right of the line x equals a and to the left of the line x equals b is equal to the integral from a to b of the function f of x dx, and that equals the antiderivative evaluated at b minus the antiderivative evaluated at a. So capital F of x is the antiderivative of the function. So what we'll be able to find is an exact area instead of a estimate of area using rectangles or trapezoids. So our example, find the area of the curve under the curve y equals x squared plus 5 from x equals 3 to x equals 6. So our area is going to equal the integral from 3 to 6. These are our lower and upper limits of integration of our function x squared plus 5 with respect to x dx. So I'm going to find the antiderivative and then evaluate it at 6, evaluate it at 3, and then subtract those two. So this is going to end up being our antiderivative evaluated at 6 minus the antiderivative evaluated at 3. So remember, when we take an indefinite integral, we have a constant. So let's take the derivative, or I'm sorry, the integral. The integral of x squared is x to the third plus over 3, plus the integral of 5 is 5x. Taking an indefinite integral, we would have a constant c, but since we're going to evaluate our function and subtract, once we subtract the two functions, the c's will cancel out, so we don't need to worry about the arbitrary constant when we're using definite integrals, because it will cancel. So we want to evaluate our function at 6, our function at 3, and then subtract. So I get 6 to the power of 3 divided by 3 plus 5 times 3. So let me get the calculator. So we get 6 to the power of 3 divided by 3 is 72 plus 3 times, oops, that should be 5 times 6, plus 5 times 6, which is 30, gives us a value of 102. Then evaluate our function at 3. We have 3 to the third divided by 3 plus 5 times 3. So that's 27 over 3, which is 9, plus 15. And we get 24. So the integral is what we get, the area is what we get when we take 102 minus 24. And we end up with an area of 78. So that means our function x squared plus 5 is a parabola that's moved up 5. The area between 3 and 6 on the x-axis, the vertical lines, the x-axis in the function and the curve, that area is equal to 78 square units. All right, so this puts together the integrals, integration, and then how do you find the area underneath the curve? So let's do a couple more examples. We're going to evaluate the definite integral from 0 to 1 of 8x times x squared plus 1 to the power of 3 dx. So we've got to use our chain rule backwards, so we're going to use a u substitution. So let's just find the integral first, and then we'll worry about the evaluating it at 1 and 0. So we're going to find the integral of x squared plus 1 to the third times 8x dx. So a reminder with u substitution, let u equal whatever's in the parentheses to the power, u equals x squared plus 1. Then find the derivative of u with respect to x. That's going to give us 2x. Multiply both sides by dx, so we get 2x dx. Now, before we do the substitution, so I know right now that I can substitute u to the third, and I have 8x dx, but I can't make a direct substitution yet because this is 2x dx. So what do you have to multiply 2x dx by to get 8x dx? Multiply both sides by 4. So when we do that, we get 4 times du is equal to 8x dx. Now that they're the same, I can substitute the 4 du. So I'm going to put the 4 in the front, du. So again, the purpose of u substitution is to get your integral in a format where you can use the power rule. So the integral of 4 times u to the third du, add 1 to the power, we get 4 times u to the 3 plus 1, which is 4, divided by 4, plus the arbitrary constant. The 4's cancel, and then substitute back in x squared plus 1, what you let u equal in the first place. So that's our indefinite integral. We want to evaluate this now, a definite integral, the area underneath this curve from 0 to 1. So we take our x squared plus 1 to the fourth, and we're going to evaluate that at 1 and at 0, and then subtract our two values. Again, we can ignore the c in the indefinite integral because when we subtract, they'll cancel each other out. So we substitute in a 1, we get 1 squared plus 1 to the fourth, that's 2 to the power of 4, which is 16. Substitute 0, we get 0 squared plus 1 to the fourth. 1 to the fourth is 1. So our definite integral is 16 minus 1, which is 15. Whatever the units are, squared. That represents the area. All right, maybe a couple more examples. Let's see, let's try number 13. We're taking the integral from 0.5 to 2.2 of the cube root of x minus 2 dx. So remember that the cube root of x is the same thing as x to the power of a third. So find our integral, use the power rule, so we get x to the power of 1/3 plus 1 over 1/3 plus 1 minus 2x, and we're going to evaluate it between 0.5 and 2.2. So let me do another simplification. 1/3 plus 1 is 4/3, so I get x to the 4/3 divided by 4/3 minus 2x. Dividing by 4/3 is the same thing as multiplying by 3/4. So my final integral is 3/4 times x to the 4/3 minus 2 times x, and we're going to evaluate that at 0.5 and 2.2, and then subtract those values. So let's substitute our first. We have 3/4 times 2.2 make sure I've got my decimal in the right place there, to the power of 4/3 minus 2 times 2.2, and we're going to subtract 3/4 times 0.5 to the power of 4/3 minus 2 times 0.5. So we throw it in the calculator. Let's see, if you want to make it a little bit easier, you can type your 3/4 x to the 4/3 minus 2x into your y equals and get the values a little quicker, or you can just type it in the calculator. So let's see, we have 3/4, which is, we put big parentheses, 0.75 times 2.2 parentheses to the power of 4/3. So put parentheses around your 4/3. Minus 2 times 2.2 is minus 4.4. Then we're going to take minus parentheses 3/4, which is 0.75, times 0.5 to the power of 4/3, parentheses around your power, minus 2 times 0.5, which is 1. Close the parentheses. I just want to go back and make sure I've got everything typed in right. Okay, hit enter, and we get a negative 1.55166. So that means the area, how did we end up with a negative? So on here, whatever our function looks like, this is the cube root of x minus 2, so it's going to look something like, I don't know, something like this. From 0.5 to 2.2. Part of our function is underneath the axis, part of our function is above the axis. Areas underneath the x-axis are negative, areas above the x-axis are positive. So it's accumulation of area from 0.5 to 2.2. So if you end up with a negative 1.5516, what you're ending up with, it tells you there's more of the area underneath the curve than above. So how can we do these a little bit easier or check our work? Your calculator has a finite integral function on it, math key, or you can use Wolfram Alpha or an online calculator. Finite integral was under the math key, down to FNINT, finite integral. Okay, oops. So math key, finite integral. And then type in, we're going from 0.5 to 2.2. Type your function in, cube root of x minus 2, or you can do x to the power of a half. Make sure you get inside here. Here we go. X to the power of a half, or the x to the power of a third. Minus 2 is our function. And then you have to tell the variable that you're integrating with respect to, which is x. Enter, and we get the negative 1.55166. So that's how you check your work, is you can do that on using technology. All right, one more example. Let's take a look at number 19. We've got the integral from 0 to 4 of x dx over the square root of x squared plus 9. Rewrite your integral so that you can use the chain rule backwards. We get x squared plus 9 using u substitution to the power of negative 1/2 times x dx. Take the integral. So we're going to have to use u substitution. Let u equal x squared plus 9. The derivative of u with respect to x, and then multiply both sides by dx, is going to be 2x dx. Substitute your values in. So let's see, we have 2x dx, this is x dx. Multiply both sides by a half. So now we can substitute in our integral the integral of u to the negative 1/2 times 1/2 du. Apply the power rule. So we get 1/2 times u to the power of negative 1/2 plus 1, which is 1/2, divided by a half. We don't need the arbitrary constant because we're going to substitute values in. The halves cancel. We get u to the power of a half, and substitute back in your original, what you let u equal, x squared plus 9 to the power of a half. Now we're going to evaluate that at 4 and 0, and then subtract. So remember, a power of a half is just the square root. So we have the square root of 4 squared plus 9. 16 plus 9 is 25, so that's 5. And then the square root of 0 squared plus 9, which equals 3. 5 minus 3 is equal to 2. So the area between this function, the x-axis, and vertical lines 0 and 4 is a cumulative area of 2.